Hi, CP Algebra 1 stir here. This is SLI number 8's notes. So let's take a look at this. So from these, we just want to go ahead and let's write the inequality from this. So I know that I'm going to have -1 and 5, and I'm going to have x in the middle. Do I include any of my endpoints? The answer is no. If I wanted, so this is the inequality that goes with it. If I wanted to write this in interval notation, it would go from the 1 to 5, and they are soft brackets on each. Okay, this one, let's create our inequality. So look, they gave us the interval notation. We have square brackets on both. So there's our inequality. And if I were to graph this, I'd have 5, and I'd have 9. I guess I could have spread these out a lot more. But I have solid dots on both and shade in between. Okay? And so here's the inequality right there. This next one, we want to go ahead and solve it, so I'm going to subtract 5 from both sides. So I'm going to get x is less than or equal to -7. So if I have -7 here, I have a solid dot, shading it left, so that's going to infinity, negative infinity. If I want to write the interval notation, I read it from left to right, so I go from negative infinity, soft bracket, to -7, hard bracket on -7 because I have an equal sign. Okay, for this one, let's go ahead and subtract 3k from both sides. I'm going to bring this down here. So that's going to give me -k is greater than 4. So at this point, I would want to multiply both sides by -1. So those cancel, so I get k. Remember, this sign has to flip over. Okay, so if I have -4 on our number line, I have an open dot, and I want less than. So that's going to negative infinity. My interval notation is going to go from negative infinity to -4, soft bracket. Soft bracket because I don't have an equal sign. This is one of those we want to clear the denominator. So 2, 3, and 6. So I'm going to multiply everything by 6. If I multiply everything by 6, this cancels. So I get 3w plus 3 goes into 6 twice. 2 times 1 is less than 6 goes in there. That's 5. Subtract 2 from both sides. Let's bring this down underneath. So I get 3w is less than 3. Divide each side by 3. So w is less than 1. So if I have 1 here, I have an open dot, shading it this way. That goes to negative infinity. The interval notation, read it from left to right. So negative infinity to 1, rounded bracket. Okay, this one, I've got to remember, I have to distribute the -2. That's going to give me -12 minus 10n. Combine my like terms. And then let's start solving it. Maybe add 10n to both sides. 10n, sorry. And then subtract 7 from each side. And divide by 15. Do I flip the signs on this one? No, I did not divide by a negative. Yes, this is a negative, but this right here was positive, so that's when it would tell me to flip my signs. So on our number line, this is going to look like this. Solid dot going this way forever. That goes to infinity. Let's write the interval notation, read it left to right. So hard bracket from -1 to infinity. And there we go. Remember, any questions you might have about these, please bring to class. We can go over. Okay, this is our or statement. So remember the or, we only have to look for where it's true on both or true on one or the other. So I'm going to subtract 5 from each side. Divide each side by -2. Ooh, I'm dividing by negative. What happens? That's right, the sign flips over. So I get -2. And let me finish this before I graph it. So I'm going to combine like terms over here. Subtract 4y. So I get y is greater than 5. Cool, so now I can go ahead and put it on my number line. So -2, open dot going this way. And 5 here, open dot going this way. So that's going to negative infinity. That's going to positive infinity. So this is an or statement. So that means that we can go ahead and go from negative infinity to -2 soft bracket 5 to infinity. And the reason this works is that's an OR. If this was an AND statement, we would have no solution, but because it's OR, we have it work. Another OR statement. So I have 5 here, I have 3 here. So I have an open dot on 3 going this way, I have an open dot on 5 going this way. There is indeed an overlap. That's where our AND takes place, but we do have the word OR. Okay? So our interval notation here is going to go from negative infinity to positive infinity because we only need a part of it to be true. And then same exact problem. I have a 3 and I have a 5. Open dot at 3 going this way. Open dot at the 5 going this way. Okay, is there an overlap on this problem? This is where the overlap would take place. It's not there, so my answer to this one is empty set. There's no solution. Okay, questions about that, please bring the class. Make sure you're doing your homework that's assigned. Have a great day, everybody. Take care of one another.